Yeah, welcome everybody. Hello, and welcome to today's Strength in Numbers webinar session. And for you who watched last week's session with Matt Price from the LA Kings, he did a phenomenal job. Welcome back. And for the newcomers, I want to thank you for joining this series here. And this is something that we will be doing here for a while during the spring. I hope that everyone is doing well and that you found a good and productive way to live and work this new situation. It's a weird thing for all of us, and I sincerely hope that your family and friends are doing well. My name is Peter Holmertz. I'm the head of 10 Motion for North America, and I have the honor to introduce these sessions. We are going to switch slides here, see if I can get that going. There we go. We have a worldwide audience, and these will be weekly 1-hour sessions with a Q&A session at the end. And today we will probably also do a recorded Q&A that we will send out to you afterwards, because we tend to get a lot of questions. And we also record these sessions and we post them after the webinar on the 10 Motion website. So you can find them and view them after the fact. The ones facilitating are myself, Peter Holmertz, and my colleague in Norway, Dr. Ola Eriksrud, and Adam Rolfe, my colleague here in Texas, who is in San Antonio. I have the great honor today to introduce Fabian Lüthy and Jan Seiler from the Swiss Federal Institute of Sports. Fabian here, who you can see, he is a scientist and strength and conditioning expert who born and raised in Bern, Switzerland. He has a master in sports and specialization in elite sports from the University of Salzburg. He has combined 18 years of experience in strength and conditioning. He has been working for 13 or more years as a strength and speed diagnostician. There you go, that's a hard word for me. And 12 years as a university lecturer. His colleague who's going to join us here is Jan Seiler, also a strength and conditioning expert, born in Breg, Switzerland, and has worked a lot in alpine skiing and about 10 years in strength and conditioning. Master in sports with a specialization in elite sports from EHSM in Maglingen in Switzerland. And he has 2 years of experience as a head strength and conditioning rehab expert for the Swiss ski team, and 1 year strength and conditioning supervisor for competitive sports in the Swiss Armed Forces. So with that, I'd like to welcome Fabian and Jan to join here on camera. I'm going to hand over to Jan here as a presenter. There we are. And Fabian, are you there as well? Well, let's give Fabian, you got to activate your web camera, Fabian. There you are. Can you guys hear me?
Perfect.
Good, good. So thank you both for being here. What time is it in Switzerland? Yeah, Fabian's microphone is turned off right here. So let's find some sound for him. Fabian, you need to unmute your microphone.
So now I'm online. You hear me?
There we go. Good. There we go. There we go. Jan, we can hear you okay?
Yes.
Oh, good, good. Well, thank you so much, guys, for being here. We really appreciate you preparing for this. We know you've been working hard for the last week or so, and there's a lot of interest in your presentation. We had close to 350 people signed up here for the session. So yeah, and you have an audience, people in North America and Europe mainly, but also a few people from Asia, Australia are watching. So welcome to everyone who's here. And I'll hand over to you guys and do your presentation. One little note, we had a little technical issue with the videos you're gonna play. So I'm going to play those from my computer, okay? So whenever the time for video, let me know, and I'll get to my computer. I'm going to play the videos. We have 3 videos we're going to play for the audience. So welcome everybody. Jan and Fabian, take it away.
Thank you, Peter.
Thank you.
First of all, thank you, 1080, for organizing this webinar and give us the possibility to talk about eccentric training, especially to the topic accentuated eccentric loading. 15 years ago, I'm sitting on a bike. It was a special bike. It's called eccentric bike. You sit on this and the pedal are motorized and they turn backwards. You sit on the bike and you have to brake. They said to me, Fabian, can you brake against the pedals for 3 or 4 minutes? I said, no problem, I did it. And after this, I couldn't walk for 1 week. I had so many muscle problems that I have to go backwards the stairs because I had no chance. So I knew that this is a very interesting stimulus, this kind of eccentric training. 2016, we bought the first machine, the 1080. And with this, also the interest about this accentuated eccentric loading growing in me. Because with the machine, you can play with the eccentric part of the movement very, very good. So I start trying training sessions. I start also training or looking for the science around it. And so we just come up here to give you this webinar about it. My friend Jan, how are you?
I'm good. Hello, everyone. So I'm also glad to be here and to present something on the accentuated eccentric loading. So my background, as you saw before, is in alpine skiing. So alpine skiing is the eccentric muscle work is dominant. So there have always been a lot of interest how to train eccentrically in the dryland training. And that's also how I ended up in Mocklingen with the new machine, especially with the new 1080 system. And that made a lot of training modalities possible, especially for the eccentric part of movements. So first of all, I think we will go quickly to the point, okay, what is eccentric muscle work? So there are 2 main types of eccentric muscle work. So eccentric muscle work, it can be a shock absorber. So you're just breaking the movement without any stretch shortening cycle. So the energy is gonna dissipating. That's one kind of eccentric muscle work, which is, as you see here, can be in downhill walking or also in alpine skiing. Then the other mode is when the musculature eccentric to concentric is acting like a spring. So the energy from the eccentric muscle work is recoiled to the concentric part, and that is creating a stretch shortening cycle. A stretch shortening cycle which can be slower in a normal or in a running gait, or which can be fast, which is the case when you are sprinting, for example. Fabian, you want to add something to that?
No, I think it's clear for the moment, so we can go forward.
Okay, so let's switch over to the force velocity profile, Fabian.
So on the right side of this profile of this graph, you see the concentric part of a muscle contraction. So if you click on, we can see it, yeah, right. On the left side of this graph, you see the eccentric part. So of course, it's difficult for some people to read some graphs, but this graph is very popular starting in the 1930s with Hill. So he isolated muscles, single muscles, and look how they are working in the eccentric part or also in the concentric part. So what we see here, so first of all, horizontal, you see the velocity, and the first point is when you have when you want to make a high velocity, and the concentric part, you need a light load. So when you make a bench press and you want to make fast bench press in the concentric way, you try to push as hard as you can. You have to lower down the load. So on the other side, when you higher up the load, everybody knows this, the speed is going down. So it goes down slightly till most of the end of the movement. So it's 20 centimeters per second for the 1 repetition maximum in bench press. So it's very, very slow movement. And it shows that in the concentric way, you have this kind of 2 possibilities. So when the load is high, the movement is slow. And when the load is light, then you can move it very fast. So, but how does it work in the eccentric part of the movement? So we take the same. So if we go down with a bar in a bench press, we are capable to take more load in the eccentric way. And interestingly, we can also produce more speed. So we can go up with the load and produce more speed. This is not typical because in the concentric way, it's the other way around. So here we can say we can have a high force with low velocity, or we can also have a high force with high velocity. And this, of course, is interesting because it's different to the normal way we know it from the concentric way. So maybe we go one more in the front, or you want to add something, Jan, to the start?
Good. Go on.
So here you see an exercise on it. So you see the guy, he's sitting, make a bench press and have 80% of the 1 repetition maximum in the concentric way. And in the eccentric way, with a system that help him, he can do some more load. So in this kind of picture, he took 100%, 120% of the 1 RM in the concentric way. So he can take more load in the eccentric phase. So this is a kind of exercise we use in this eccentric overload training. And as you see, it's not that easy to have equipment that help us. So maybe Jan, you can help us to give us information about the equipment to use for this kind of training.
Yeah, so as you can see here on that picture, you need to add more load on the eccentric part. So that can be done by different options. So weight releasers is a possibility, or maybe someone that is adding manually plates on a machine. So this is one way. But then we have also electric motor driven systems, as we're going to see later on. And that's where 1080 quantum system is playing a really, really important role for us in the daily work, because you can do really a lot of different combinations of eccentric and concentric loading, or playing around with the velocities. So this is really, really useful for us in our daily practice.
Yeah,
so let's go on to the structure.
Yeah, Jan, we just both thinking a lot about how we can structuring this application of AEL, and we want to try to do it on the same graph as before. So you see on the right side the concentric phase of the movement you do, or the exercise you do, and on the left side the eccentric part. So what happened right now is when I do eccentric overloading, I have the possibility that the load is higher in the eccentric part. So you can push animated, Jan. Yeah, genau. So you see in between 1 repetition, the load could be higher in the eccentric part than in the concentric part. So this kind of training, we call it high eccentric loading, because we change the load in between the movement. So if you want to give them a short name, we call it AEL, as high eccentric loading. So typically for this high eccentric loading is that we can make a difference in the training with the high eccentric load. And it is so, if the load, if you can move or stop the load in the concentric way, and you can stop it whenever you want, and you can go in the other direction. So you can push to the next slide, Jan. Then you can see that here is a good example. So you have this 40% of the 1 RM in the concentric way. It's a light load. And so you add some load in the eccentric phase, maybe 60. Yeah? So if it's 40 kilogram here, I take 60 kilogram in the eccentric part. So, but because I can move 100 kilogram, so this means that I can stop the movement whenever I want, and I can also go to the concentric way. So this kind of high eccentric loading we call submaximal AEL or high eccentric loading. But the specialty about eccentric loading is that we can also train with a load that is much more higher. So in this case, we take 80 kilogram. 100 kilogram is our 1 repetition maximum. And as we saw it before, we can take 120 kilogram in the eccentric phase. So if we have exercise like this, we make a structuring or a characterization that we call this supramaximal high eccentric loading. So the character about load means the load is higher than the concentric load all the time, but we make the difference if the load is higher than the 1 repetition in concentric way or not. So load is one way to have the intensity of the eccentric training, but Jan, we have also another possibility to have a higher intensity in the eccentric phase.
Yeah, exactly. So we can maintain the same load for a concentric and eccentric work, but then manipulate the velocity. And that's the other part of high eccentric loading. So this is called fast eccentric loading, and we're gonna call it FEL. And we're gonna go on, and here we see the overview of those two possibilities, where you have on the left side those AEL, supramaximal or submaximal overload, and on the right side is fast eccentric loading with no overload, but for sure there can also be a combination of both, as we're gonna see later on. So what about the type of exercises? It is possible to isolate the eccentric part, which a simple example could be a depth jump, where you're not coupling to the concentric phase. Or you have the coupling to a concentric phase with a stretch shortening cycle. That could be a drop jump where you have a fast eccentric loading, but you're recoiling energy to the concentric part of the movement then.
Yeah, you see, Jan, it's complicated. We tried with another graph here. So on one way, you see the loading. On the other side, you see the velocity. These are the 2 points that we can put on more muscle tension in the eccentric phase of the movement. So if you animate it in the eccentric loading, you see if I go up with the eccentric loading, the muscle tension will be higher. And in the same way, we can also do it for the eccentric velocity. Of course, we can do the same. So if we go up with the velocity, and we know this is possible, and it's also possible to do it with high loads. So as we try to animate it, the structure, you see that it's very interesting for the muscular tension when you make a combination of AEL and FEL. So maybe Jan, you did a very nice video to try to explain a little bit this different kind of accentuated eccentric loading. Can you say something about the video who is coming soon?
Yes. So on the video, you're gonna see the 1080 quantum system. So as you're gonna see, there's no external load. So we just have the bar and cables that are pulling. So this is the motor-driven system, and we can manipulate the loading or the velocity or both. So if you look at the video, then just be pay attention to the titles, where you can see also if it's a supra or submaximal loading. And for sure, you're going to recognize if it's fast or slow. So, Peter, you can launch the first video, please.
Okay, back to you guys here. Can you can continue your slide?
Thank you, Peter.
Thanks, Peter. So we're coming back to that slide to have that overview in mind. So for sure, the exercises looked all quite similar, and the video was struggling a bit maybe, but I was also struggling a bit. So we have seen different types of loading, supra, submaximal loading. We saw also different types of velocity, and we saw also eccentric only or eccentric concentric coupling movements. So what about the acute responses to AEL, Fabian?
So maybe coming back to the 1080, our first experiences with 1080 were very simple. We just made a vertical jump and we started to additional load. So we take 5 kilogram concentric and 5 kilogram eccentric and we jump. And we saw that the machine can measure also the power, the speed, or the force. And so we look out the maximum power and then we go forward and we say, okay, we jump with concentrically 5 kilogram, but we adjust it in the eccentric part and go to 7 or 8 kilogram. And what we saw actually was that the performance in jumping in the concentric way was better. So this kind of eccentric loading, like we did it here with, we changed the load, so it was a high eccentric loading. And then we go back to the literature and we saw that also Shepard showed the same. He did a bench press and he started with 40 kilogram in the first bar, the 40 kilogram concentric and 40 kilogram eccentric, so normal exercise. It's like a throwing exercise. And he measured how far you can throw the bar. So afterwards, he added in the eccentric phase loads. So he made 60 to 40 kilograms, 70 to 40 kilogram, or 80 to 40 kilograms. So in this kind of exercise, the same we did with the 1080 for ourselves. And we saw the same and they saw the same. So you can make a progress in the performance. Here you can throw the bar much more far away. So it's interesting if you add in the eccentric phase in a submaximal way, as we heard it in the structure before. If you add some eccentric load, you can be better in the eccentric power. So you can enhance the concentric force and power output. And this is new and also interesting for us. And Jan, can you help me a little bit about the underlying mechanism here behind?
Yeah, but maybe first to add to this is especially interesting for explosive type exercises. And there seems also that the ratio between eccentric and concentric load is quite individual. So generally stronger athletes show to react more on bigger ratios, so more difference between concentric and eccentric loading. For weaker athletes, the delta is a bit smaller. So I think it is important if you are implementing those exercises that you really try to measure the concentric output to be sure that you have the right delta between eccentric and concentric load to get the most power out of it. So if you're looking to the underlying mechanisms for the acute responses, so as we go up with the eccentric load, so the rate of the eccentric force production, so eccentric rate of force development is going up. And then with this, we are creating a kind of interruption of the natural mechanics, but it's not an interruption of the movement mechanic itself, but it's in the system, because you may not be used to have an overload on a eccentric part of the movement, which is released, and then you go up with a less load for the concentric part. So this is really a neurological interruption, which is really interesting and which is aiming the system to an increased impulse of the stretch shortening cycle at the end. And this is also what is enhancing the concentric force and power output. So this is a bit the underlying mechanism. I hope that is clear like that. So now what about AEL preload, Fabian?
So what we're talking about is this acute responses. And we're thinking all the time also about practical advices. And we see 3 different fields of application where we can use it. So one is, if you take this single muscle contraction, as we saw it before, you can, in between one movement, you can accelerate the movement and you can have more power. Of course, we can use this also in a training adaptation. Maybe we see this later, but it's interesting because in one way, in one muscle contraction, you can higher up the potential of the movement. So a second one is interesting also. So if we do an exercise, I would say we make 6 repetitions and we try to do them as fast as possible. It's interesting when you do the first repetition with additional load. So this means that you go down in the first movement. You start with the first movement with eccentric overload. You go down with this eccentric overload, and then the eccentric overload disappears, and you do the whole exercise with the same load. And also here, as a consequence of this preload, we have a higher possibility to stress the neuromuscular system and to augment also here, or to have a higher power output at the end of one exercise. Another way, I think the third part is this called pop effect. It's the effect over the time. So it's an interesting part. You, Jan, you do a lot of this also as a strength and conditioning coach. Can you help us a little bit? What is the meaning about this?
Yeah, so actually we are playing a bit on high loading before we are switching to more explosive type loading with lower loads. And for sure, this can be really interesting as a pre-competition tuning or potentiation, or also in the famous contrast method. So actually what we are doing with those high overloads, we are augmenting the calcium sensitivity and also augmenting the neural drive. And this effect can be maintained over several minutes. And this is what is really interesting also in a pre-competition setting, I think. So for sure, you all heard about this pop effect, and this can really be done, I would say, easily with an eccentric overload, maybe with depth jumps or drop jumps or something like that, to be really stay with easy exercises. And this is really interesting.
So Jan, before we come to the second video, you said something about the possibility because of our structuring. So you think you can create this pop effect with the high load, so also a high eccentric loading, or do you need a fast eccentric loading, or do you think you can do both?
I think we can do both, or even a combination, because if you look at the what you mentioned before with the initial repetition only, so this in a study this has been done with an overload in slow eccentric velocity, and it worked pretty well. But if I'm thinking on a depth jump or drop jumping, we're maybe more on a not really on overloading, but more on a fast velocity side for the eccentric part. So I would say both are working. Maybe also to see for each individual which is fitting better.
Mm-hmm. It's good. So
yeah.
Jan, before we start the second video, can you say something about the idea about the second video?
So what you will see on the second video is an athlete which has both cables from the quantum 1080 quantum system attached to a vest, and she is doing counter movement jumping. So the video is going to be in slow motion. We will run it twice, so you can really see what is happening. Maybe pay attention on the muscle contraction. You're going to really see the intensity of the movement. So Peter, you can launch the second video, please. So again, we are coming back to the overview. So what we've seen here, so we had an overload and we had a fast velocity. So a combination of AEL and FEL, which is really interesting, and which Fabian is going to showing some measurements he did for this type of exercise.
So first of all, the video you saw, we made a load 30 kilogram in the eccentric phase and 10 kilogram in the concentric phase. So it means the cable left and the cable right both of them have 15 kilogram eccentric and 5 kilogram concentric. So additionally, what's coming to the body is 30 kilogram eccentric and 10 kilogram concentric. So the interesting thing is, on one way, that the strength, or it's attached at the hip. So if you do this kind of jump, as you saw the video, it was really explosive. But first of all, the stabilization in between the movement is very important, because if you are the center of body mass is not in the middle, so then you have to correct the movement before you can react. So this movement is not that easy, and we measure it on the cable. And what you see here in the first part of the slide, in the upper row, you see the concentric part of this explosive movement. Also, we did, or she did, 6 jumps. So these are 6 jumps. She did in the training session 6 times, 6 series of 6 jumps. And here you see the last series, also the 6th series, or the last jumps of the training session. Interestingly, in green is marked the maximum concentric power for these 6 jumps. And in the second row downstairs, you can maybe show it, Jan, genau. There you see the eccentric power. And you see red is the percentage of power loss to the best jump in the training session. Normally, the best jump in the training session is the first or the second series, and then the performance is going down. In this characteristic, you see that you have loss of the power in the concentric way of the movement, but also in the eccentric way of the movement. And it's about 10 to 15%. In the maximum at the last turnover, in the eccentric, was more than 20%. It's a lot for do at the total 36 jumps. So we did it a few times. This means 1 to maximum 2 times a week. So here you see the results of the 4th training session. It's the same with the same load. We not change anything, not the loading, not the speed, nothing. But what you see, it's the same last series of the jumps. And you see still in the concentric part, in the upper row, you see still this loss of power till to 10-15% after the last jumps. But interestingly, you see in the eccentric part that the power loss in the eccentric part is much more less. This means that in between 4 training sessions, we had the possibility to keep the power, the maximum concentric power, higher. And if we can keep this higher in the 6th series, we can keep this higher in the total volume. And this is interesting for us because this could also be a kind, I say a kind of chronic adaptation to this eccentric overload. In the literature, there are some studies about this kind of vertical jump. And if you see the study, it's an interesting study with volleyball players. And if you do this kind of training for a few weeks, you can jump higher after the training sessions, and also higher when you compare it with traditional training, also jump training on hurdles. So it's interesting for us. But as we have this movement, I would like to talk with Jan a little bit more also about intensity of this exercise. That's why, Jan, we make a 3rd video for the same athlete, but we show something different. What is different in the 3rd video?
Yeah, so you're gonna see the same jumps again. You're gonna also see the same jumps with a smaller or less range of motion, and you also gonna see the same systematic for unilateral jumping. So let's have a look at the video, Peter, please. Maybe you can run it again, Peter.
So Jan, sorry, did you see the video in the right speed, or was it also a little bit?
It was struggling a little bit.
Yeah. So,
but I think what is important. So we didn't change the systematic, but just the range of motion. And what we recognized, if we are working in that kind of exercises with smaller range of motion, so we didn't have a 10% loss on a concentric power on counter movement jumps. So this was really interesting because there where we have been much more on potentiation for upcoming exercises, because she did some hurdle jumps afterwards after the small range of motion AEL training, and she really felt super good and was so easy to do. So that was really impressive, and we saw it in the numbers that there was no drop in concentric power. So this was really interesting. So I think if we are manipulating the range of motion, so maybe we can also have an impact on muscular fatigue, or maybe we're working more on passive tension or tendons if we are in a smaller range of motion. And it's also something we have to play with and to plan that the right way, I think. So if we move on for the underlying mechanisms of chronic adaptation to AEL, we will not go too deep into that part, but for sure we have high levels of mechanical tension per active motor unit, but we have less motor units active, so the tension of those that are active is much higher. So this is really important and interesting. So then we have also stretch-induced strain, as we are working on the muscle lengthening, and also a greater propensity of exercise-induced muscle damage, which is creating interesting adaptations. So on the left, on a hypertrophy side, we know that there is an interesting anabolic signal for the hypertrophy, but it is more in the hypertrophy, so by adding sarcomeres in series. So the muscle length is changing, or the muscle length is changing. And what is also interesting, that we are targeting more the type 2X, so the super fast fibers. So what we often see with traditional strength training, we have a drift or a shift from type 2X to type 2A fibers. But with the eccentric training, especially with higher velocities, we can really maintain or also create hypertrophy of the type 2X fibers, which is really, really important and interesting. And for sure, on the other side, as we saw before, we have increased tendon stiffness and better storage and return of the energy in stretch shortening cycle part of the movement. And if we go on, so we will change to a faster muscle phenotype. So we have shortening velocity and force production that is better, that is going up, also because of the sarcomeres and seri that are acting. And at the end, what we all want, improvements in speed and power, which is really, really important for most of the activities and sports we are working with. So, Fabian, let's talk about the study you did, Christoph shared. It's really interesting.
Maybe before beginning of the second part here of the supramaximal overload. So in the beginning, I talk about this eccentric bike and my experience with this bike. Afterwards, we did a study with it, and we saw an interesting thing that if you do eccentric training on a bike, on a cycle with a motor-driven system, after it was 4 weeks of training, you jump higher. So interestingly, normally when you do cycling, you not jump higher because cycling is not a movement in the concentric way that helps you to jump higher. But in the eccentric way, it's very interesting. And maybe one idea behind is that what Jan is showing before, that the contraction velocity is growing, maybe because the possibility of the muscle to get the strength in a longer condition would be one of the points maybe. So if you go to supramaximal overload, so now we have a load that we cannot control. So control mean we cannot stop and go in the concentric way, so we have to manage this eccentric part. And in one sport, this is very interesting. We have did it with artistic gymnasts, and it's a kind of imitation of an exercise part on the rings. So it's a swallow, and it's a 180% different because you're lying and the rings are coming to you than when you do a swallow. But what we have done, or what was our interest? So we just used this eccentric boost. So the guys who don't know the 1080 motion, it's interesting that you have an application that calls boost, and this is a very slow movement. It's 0.1 meters per second, but you have no chance to brake against it. So it's an isokinetic, slow, eccentric movement. And this movement, we made a combination to have a higher load in make a cluster setting. We saw in the literature till now that there were not many experiences about cluster setting for eccentric training. Cluster setting is used when you want to have a faster way to get more power out of your muscles. So it's used for normal squats or other type of exercises, but especially eccentric only, this clustering is very rare. So what we did, we did 4 reps in a row, and then we gave the athletes 20 seconds of a rest. And then we did the second 4 reps. And then we did the third 4 reps, and then the fourth 4 reps. This was one series. Then we make a break in between 5 minutes, so enough to recover. And then we do it twice or third sets, depending a little bit the planning we had. But so the total reps we did was between 24 and 48 in a session. And we did it twice a week during the whole training period. This means that the athletes, gymnastics athlete trains a lot with a lot of training sessions a week. So they regularly train, and we addition this kind of training. So we did it for 4 weeks. And if I say we did it, it was Christoph Scharer, our colleague in our team, who did this, and he also published all the interesting results. So if you are interested, you see it on the slide, or you can go to PubMed and find it if you call out for Scharer and this kind of training. But what happened? So if you see here one more time, you see, okay, it was this time a high eccentric loading. And this high eccentric loading was very slow, and it was a supramaximal overload. So now we find us on the slide on the left side. So it was a supramaximal overload, higher than 1 repetition concentric maximum, and it was very slow. So eccentric only. So, okay, what happened? Here you see also measured from the machine the maximum eccentric force during the training sessions. And what you see is T1 to T8 are the 8 training sessions twice a week. And you see after 2 weeks, the second training session in the second week and the third training session, also the fifth training session in the third week were the best. Means that in this type or time, the athletes make a progress in the maximum eccentric force. So so we have a rapid development of the maximum eccentric force. So this is not typically if we do some training studies. So after 4 or 5 training sessions to get already the peak of an exercise is very interesting. And as you can see here, afterwards, they're not getting higher. They try to keep it for the 8 sessions. So at the end, but what happened with this? So if we come back to the training specific exercise, we see on the right side this swallow. As for the testing circumstances, the target was to hold the swallow for 5 seconds. So test 1 on the left bar, you see test 1 was before the whole training sessions, and you see the target was to hold for 5 seconds. That's why the athletes had additional load that helps them, a counter load that helps to keep your body for 5 seconds in this position. What happened? After the training sessions, 1 week and several weeks later, you see that we have the capacity to hold the same exercise for the double of time. So we not hold it for 5 seconds, so the athlete hold them for more than 10 seconds. So it was 100% more holding time than before. So what we want to say about it, we just want to try with this kind of exercise that or this kind of study, we want to try to help to understand what happened in the chronic adaptation. And in my experiences, it's very difficult to get the right load and the right speed for your exercises or your target you know. Here in this way, it was clear, it was a swallow, they have to hold, so it's very clear that we work with slow movement and high eccentric. But maybe for other movements, it's not that easy. So I can imagine, Jan, if you come back to alpine skiing, this will be not the best exercise for alpine skiing. Would you suggest to do another one?
Maybe more working on the legs for sure. But at the end, in alpine skiing, as I said at the beginning, we have also really high external forces acting on the body. And we are almost always in eccentric dominance or quasi-isometric muscle work. And this repeatedly for a minute or even longer. So I think that kind of increasing force in a short time is really, really interesting. And I mean, we are talking about experienced athletes. It's not untrained people. So it's even more interesting that they are reacting that quickly on stimuluses like that. So, but the question is also what is going to happen after the adaptation, that quick adaptation, if you want to go further. And as we saw, we had here high loading, really slow eccentric velocity. So that's where maybe you have to play with velocity thereafter. So switching to more fast velocities to go a step further away. But I think generally this is also difficult to plan because the combination of high load and high velocity is also a kind of danger when you go to a certain amount of load and velocity. So I think we must really be progressive in creating and programming those eccentric trainings. So I think we are almost done with our presentation, Fabian.
Oh yeah, question.
So maybe we can switch over to questions.
This Peter breaking in here. just want to let everybody know there's 4 minutes left on the clock for the hour presentation, but we can go on for a few minutes, so anybody is welcome to hang on here and continue. You can also, if you don't know that yet, you can type in your questions on the webinar tool, so we can get some more questions. And we will also do a recorded post webinar with Jan and Fabian to discuss the questions that are coming up here. So we will cover and answer all of them. I want to welcome Adam and Ola here to the panel and for the Q&A.
Why don't I start off? First off, thank you for this great presentation. Certainly enjoyed it. So I'm going to cut right to it. The use of this kind of resistance, or this, whether you use higher loads eccentrically or higher rates eccentrically, some considerations as to where would you put that in a longer plan, meaning would you put that more in the pre-season? Do you use it in season, or do you use it post-season, or do you mix that up? Have you had any experiences in that regards?
So Jan, you want to begin?
Yeah, but I think maybe what's really important also that people has to get used to that kind of eccentric work. So as we know, it is creating a lot of muscle damage at the beginning. So I think we should also have a part in our preparation where we are trying to get used to that work with our athletes. And as we saw, so if you're going closer to competitions, we can tuning something with that kind of loading. So if we are thinking about maybe more high velocity type loading, where we are less on time under tension, so maybe you're reducing a bit of fatigue, but have a really important stimulus due to high velocities, high eccentric velocities, that can really act as an acute response and an acute stimulus to increase the explosiveness or power for upcoming competitions. I think that's really important, but the way to go to that point, I think that it must be a bit longer. It must be longer over some years where you're preparing athletes to that kind of exercises, and it needs also some kind of preparation during the season for sure. What's your experience, Fabian, with that?
I think when I heard the talk last week from Matt, who did, when we take the same language, we can say he took high concentric loading and a kind of isokinetic but concentric loading, and he explained that he can do this 4 times a week during the whole season. So the eccentric, high eccentric loading, I think you can do it once a week. So, but you have to do it regularly. If you not do it regularly and you're not prepared to it, as Jan told before, I think you get a fatigue in the athlete that you not bring out in a 1 week or 2 weeks. So my experience about this is also during the season. If you have trained this in the pre-season, you can use it once a week. But you have to find different aspects of this eccentric loading. So you can do it with a high load or with less repetitions, but you can do it also with a fast load. So a fast eccentric loading. But for me, the most important thing is when you do this, wherever you are, don't do too much. Just go once a week and don't do too much muscle contractions, because this can limit your performance in the next days or weeks. In one of my experiences when I was younger and tried really to push hard in bobsled, I had an athlete who was not capable to run and push the bob for 6 weeks, because we pushed too much in the preparation with this eccentric overload system. We had a pneumatic system that helps a lot in squatting, but it was too much, and we had really to wait till the recovery is coming. And this is be careful about the loading. This is my suggestion.
No, and I think that's a valid point, because Matt last week, he was talking about this micro dosing that he was distributing, and he was using that distribution a little differently dependent upon playing time. So he was using that in combination with the load management on the team. So that makes a whole lot of sense. Which also brings me kind of into the next question, and you touched upon it a little bit, because when you start up this eccentric, and you become very systematic in doing so. Do you start heavy and slow, or do you go fast and lighter on the eccentric side? Do you only do the eccentric component, or do you also do the eccentric and the concentric component? Do you have, say you have someone who's kind of new to this kind of stimuli, how would you kind of start that person out to be familiar with it? Slow and heavy versus a little faster and lighter on the eccentric side, or have you had any thoughts or experiences in that regards? If my question made any sense whatsoever.
Yes, so maybe before we are talking about really high eccentric loading, there are other possibilities to prepare athletes for that kind of work. So I think to work on a big range of motion, so that you really are used to work on the whole muscle length, is really important. And then maybe create that with submaximal overloading first, and then coming up to those super maximal loading combinations. But for sure, as you saw on the graph where we talked about mechanical tension, so once you're really high with the load, so you can start to play with velocity, but maybe on a first step you have to reduce load when you go up with the velocity, and then stay with that velocity and come up with the load again, and go step by step on both sides to that higher and higher muscular tension, I think.
So my experience to it, you can also do a little bit of help the athletes when you do only single contractions or a few eccentric contractions, as we showed in the presentation for acute responses. So if you do only one or two in one series or one training session, you do it with a higher load. So like high eccentric loading. In other session, you do it with a fast eccentric loading, but you make it in a combination with normal loads. I think then you feel very good. Also the athlete, and if you ask the athlete, you will recognize which of this system is actually the good one. So one of my helps to you is, okay, try it to use it as a preload, and to look how this preload react to the movement. And because when the preload is not stimulating the loads afterwards, then it's not the right time to it. So in the literature, there is a lot of it, but one thing that I used was very simple. They said, okay, if you do some drop jumps, 5 drop jumps before you squatting, the performance in squatting will be better. And if you do a drop jump, it's a fast eccentric loading. And I did it with athletes, and I really realized that when they do squatting afterwards, most of the athletes, they had a good feeling and a better speed in the concentric way. So, but there were also athletes who are not react to this. So they were not capable to break, or this resistant exercise was too intensive for them. So I know, okay, this fast eccentric, even if it's a simple one, it was too much. So I tried in this way, not too dose too much and look for the reaction, because it's happened very fast, and then you know it, or you can help.
Thank you. Peter here. Can we take one more question, and then we will, as I said, follow up with a recorded version of a Q&A here that we take here. There's lots of questions coming in, so let's take one more question, and then everybody will have their answers in a day or so after the webinar.
Yeah, absolutely. There are some brilliant questions coming in. I have one. You were talking about stiffness, and in terms of ankle foot stiffness, that is important in running and jumping. Obviously, there were some bigger lower body movements that you were showing, and you were not necessarily targeting the ankle. Do you have any experiences as to ankle stiffness and targeting the ankle foot complex in applying these kind of loading strategies? Have you explored that?
Yeah. So I say for the vertical jump, I have not that much experiences. But interestingly, when you do some resisted sprints with the 1080 sprint system, we realize that it also helps for this kind of stiffness, because the force you produce is in the horizontal way, and it's important that the ankle can take the load from the floor to the body. So we saw it, and for us, of course, it's interesting because in a lot of sports we want to go horizontally, and that's why we use it in this kind of movement, very specific with additional load. And here we see that we did it also with gymnastics in a training intervention, and we saw also that maybe this ankle, so this ankle help in the stabilization and help also for the horizontal performance. So in my opinion, with the vertical jump, I have not that much experiences. Maybe Jan can add, but I think interesting is with resisted sprints.
Sorry, so I haven't heard the question. I haven't heard your answer. There was a technical problem. Sorry for that.
I'll try to rephrase it.
I think you add.
I can repeat it. Ankle.
I think we lost Ola there. No, the sound is, I don't know if the audience can hear me. I hope so. Let's finish here. And thank you so much, Jan and Fabian, for doing this presentation. Thank you very much. There's some glitch here with our sound. I don't know if anyone can see or hear me now, but to finish this off, just want to highlight next week's presentation. We will be joined by Chris Stackpole and Devin McConnell with the New Jersey Devils, and they will talk about the transfer skills from the weight room to in-sport performance in hockey, and they will generalize that to other sports as well. So next Thursday, it's on Thursday, not Wednesday, Thursday next week. We hope you can join us for that one. And with that, I want to say thank you so much for joining today. We'll follow up with emails, with a Q&A session, and we hope that you will join us here in the future. Thank you so much, and have a great rest of your week. Have a good weekend. Stay safe, everyone, and a good evening, good night, good day. Bye now.